In this session, we want to discuss routing. In our scenario here, we have two networks, network A and network B. The network address for network A is 10.10.50, and the network address for network B is 10.10.20. What we want to do is to allow traffic to move from one network to the other network. Now let's look at network A. Let us say, for example, that a computer 10.10.52 wanted to communicate with a server or another computer on network A. What will happen is that when the request is sent out, when the traffic is sent to the other computer, the network will know that that computer or that server belongs to the same network because all of them will have the same address. Each of these client computers will have 10.10.5 as their network address. So will the server. So there will be no problem with traffic movement. And if someone at 10.10.52 wanted a file, a folder, or any other information from any of the computers on the network, they only need to contact that computer or that server. Once they have permission to access that data, they will be able to access the data. But let us say that 10.10.52 wanted to access data on network B on a computer, for example, whose IP address was 10.10.26, a completely different network from network A. They're not going to be able to communicate because they're on two separate networks. So that's where our router comes in. What will happen is that that traffic will go through the interface, which would be the default gateway address, and then it will go to network B. So the router will route the packet to network B. But how does the router know where to send the packet? The router has what we call an IP routing table. And this IP table shows the routes for all the other networks. Some networks advertise their routes. They advertise addresses, destination addresses, and subnet mask and default gateway, so that the routers automatically pick up that information. So that if you send out traffic to a computer or server on another network, what will happen then is that that request will go through the router. The router will look at its routing table and say, well, let me see. This destination address, I know what network this is on because my routing table shows me where the default gateway for this particular network address is. Let us take a look at the routing table. To take a look at the routing table, we're going to go into routing and remote access. Going to expand IP4, and we want to click on general here. And we can see here the adapters. You can see that we have the CorpNet adapter here that is connected to 192.168.10.1. That's the IP address. And then we have the CorpNet 2 that is connected to a different network, 192.168.11. Those are two separate networks. We're going to right click on the CorpNet network, and we want to click on Show IP Routing Table. And let's talk about the routing table. The routing table shows the destination address. So I can say if a destination address is this or a destination is that, then I'm going to send you to a particular gateway, which would be your default gateway. That's the IP address that you would have for your network for communication in and out of the network. So let's say if my destination address was 10.10.01, then on your routing table, the gateway will show you the gateway that you need to access. In our example here, you can see that this particular address is connected to the same network. So there's no gateway here. You don't need to go out because the address is within the particular network. But what if you had another destination address? What the table would show then is the gateway for that address. So the whole point is with routing. Routing sends your traffic to a destination outside of your network. So if you said that you wanted to go to 192.168.11.5, for example, and that address was on a separate network from the network that you are, you would have to be routed through the gateway. And the routing table would say which gateway you need to go through to access that particular destination address. Very simple to read the routing table. Then, of course, you have the interfaces. We also have the metric. With the metric number, the lower the number, the more that particular route is preferred. For example, you might have 2 routes to a particular network. But if one of the routes have a lower metric, then that is your preferred route. That is the route that will be taken first. So the routing table is really the key that will allow your network packet to go to a particular network. Remember, if the packet is destined for the same network that you're on, you don't need to go through the gateway. You just connect to that computer or to that server. If the destination address is outside of your network, let's say you wanted a file or a folder, but this file or folder is on a server or a computer in another network, then automatically your traffic will be sent through the router. And the router will have that gateway address of that packet, and it would forward the packet through that particular gateway to that network. How does the routing table gather information? Because routers advertise their routes. So one router will say, okay, I have the gateway for this particular network address. Just make sure that you get this information so that if someone sends a request through the router will know where to find that particular destination address. Let's close the routing table. We're going to right-click CorpNet, and we're going to click on Properties because we want to look at some of these properties under the General tab. Under the General tab, you have here Enable IP Router Manager, so you see that's there by default. Then under that, you have Enable Router Discovery Advertisement. So once you have that, when the other routers advertise their routes, your router will receive that information. Sometimes a router might not actually have a particular route for a destination address, and we actually have to create that route. And that's what we call static routes. So we're going to click OK and close the CorpNet property box, and we want to create a static route. So we're going to right click on static route and say new static route. And we're going to create the destination. Just click in the destination box and we're going to type 192.168.1.0. For the network mask, we're going to type 255.255.255.0. For the gateway, let us, for example, do 10, 10, 10, 1. So we're actually typing in a particular route. You're given the destination, you're given the network mask and the gateway. So you're actually putting this information in the router. So when someone requests this destination, your router will know to use the gateway 10.10.10.1. Please note that in our example for our lab, we're using the gateway 10.10.10.1, but in your production environment, you would want your gateway, your router address for that part of the network to be on the same network as the destination that you are referring to. So please bear that in mind. We're only doing this for our lab exercise. We want to click on OK. Now let's go back. I right click and say show IP routing table to see if we see that static route that we entered just now. And here it is, 192.168.1.0. And the default gateway is 10.10.10.1. The routing table can also be shown using a command line prompt, and routes can also be added using a command line prompt. Let's take a look at that. That might be one of the questions that you would get in exam. At your command prompt, to show the routing table, you type the words route print. If you need to add a route at your command line, you type route at, you type the destination address, the word mask, you type the subnet mask, and you also type the gateway address. Then you type the word metric, and you type the metric number. And then you also have to type the interface number, depending on what interface you're dealing with. To delete that route at the command prompt, you simply type delete route and the address of the route. I want you to remember the order in which you add the route at the command line. Remember what comes first, what comes second? Very good question for an exam. This is the end of our session on routing, and I want to thank you for listening.